Assalamualaikum and hello to my panel Sir Mustafa bin Manap and Dr. Muhammad Hatta bin Jopri. My name is Nur Alia binti Zulkifli, metric number B081810470, and my supervisor is Sir Ahmad Zubi bin Jamil. Today, I will present my PSM2 and the title of my project is Development of IoT Based Smart Energy Meter. Next slide, I introduce the purpose of doing this project. In order to analyze and control power consumption, an appropriate system must be developed. As a result, of course, the smart energy meter is the solution to this problem. So, this paper demonstrates the IoT-based system in which the consumer as well as the service provider will get the use energy reading with the respective amount at each time interval. This will assist to save electricity by ensuring that loads are used efficiently. Design for what? The demand for electricity has increased as a result of the rapid expansion in human population and humans' reliance on electrical energy. So, a smart energy system is being developed especially for residential clients. Next, I will explain more the details in poster project. This is the full poster development of IoT-based smart energy meter. Next, I will explain one by one according to the introduction, objective, problem statement, methodology, result analysis, and to continue the conclusion. This project purpose is on IoT-based smart energy meter. This project provides consumer and energy provider real-time energy monitoring system at predicted interval by using features of data or notification from ThinkSpeak, which is combination of Arduino and Node MCU ESP8266 as microcontrollers. Moreover, the objective of these projects are to measure total power consumption using the current, voltage, and power values from a digital energy meter within a range of time. Second, to develop a real-time platform for collecting data on building energy consumption and reduce the amount of energy wasted. The last one is to implement and develop a low-cost wireless automated digital energy meter with IoT concept and reduce the need for manual labor. Move to the problem statement in this project. Firstly, conventional method and SMS application remain costly in data monitoring. As IoT is less expensive than SMS, it is possible to monitor energy usage at a reduced cost. Second, this method needs extensive info for data analysis. This demands the collection of enough data for analysis, which involve the real-time acquisition and transfer of data from many sources, high processing power, and data storage capacity. The last one is application of physical smart meter, still expensive and need proper maintenance. The task of reading the meter will be made simpler with a wireless digital energy meter. The methodology for this chapter will explain the method used to achieve the project objective that will accomplish a perfect result. The flowchart is significant for illustrating the sequence of the operation. Each step is represented as a different symbol and explanation of the process. And the block diagram will represent the software and hardware component to purpose IoT in my smart energy meter. Based on the block diagram, the total control system depends on the single board Arduino Uno microcontroller. For the hardware, we are using energy meter, loads such as toaster and hairdryer, single channel relay, voltage sensor, current sensor, LCD display, Node MCU ESP8266, and PCB board and jumper for the connection. ThinkSpeak is functioned as a software to receive data from Node MCU. For flowchart results, we will be shown the process according to the video demonstration. On top of that, the result for this project will show further demonstration on the video. So, this is my final product of the project that use of energy meter, plug for loads, single channel relay, voltage sensor, current sensor, LCD display, Arduino, Node MCU, hair dryer as one of the nodes, and the most important parts in this project, of course, ThinkSpeak. For the circuit connection, I use the PCB board and the jumper. To run the program, we have to on the plug to get supply connection for energy meter. Now, I will explain on how the project works. As previously said, the base smart energy meter system is designed using software and hardware. The Arduino, Node MCU, current sensor, voltage sensor, and relay are the main hardware components in this project. In this project, the energy meter will display the energy that have been used by consumer, while the LCD will display the connection of Node MCU and ThinkSpeak. The current is calculated by the current sensor using the indirect sensing technique. The sensors sense data can be viewed in the ThinkSpeak. Next, the voltage sensor is used to monitor AC voltage. With this module, we can measure AC voltage up to 250 volt. Furthermore, Node MCU is employed as the project's primary core and communication tool. Power and Wi-Fi must be connected to the project before it can begin. The sensor's output will be sent to the Node MCU where it will be processed. As you can see here, as soon as the load is on supply, the graph automatically changes according to the load used. Furthermore, the function of relay is to be energized and cutting off the main supply. When the price exceeds the stated price, a relay is utilized to disconnect the main power supply on this project. The set price for this project is below 3 cents. As you can see here, the relay will cut off as soon as the price is more or equal than 3 cents and the graph will be like this. This operation is designed to keep consumers informed about their energy consumption and to monitor and then track their usage in order to save money and energy. In this project, ThinkSpeak is also a crucial communication and data interpreter tool. Among the widgets displayed are current, real power, voltage, and energy. For this project, there were 3 main types of loads used to determine the current, voltage, real power, and energy usage. Toaster, hairdryer, and fan were among the loads used. Each data reading is saved for comparing different loads and scopes of requirements. Real meter readings from the residents were used to calculate the power consumption. For conclusion, this paper presented an Internet of Things based smart energy meter that may be used in residential and commercial buildings to detect power consumption at the device level without affecting current appliance operation or requiring extensive rewiring. Two-way communication between ThinkSpeak and the smart meter is stated as one of the key features of a smart metering application. At least daily data transmission to the monitoring system. The cost of developing this system could be reduced significantly in the near future by employing more efficient technology and commercializing it through large-scale production, lowering production costs dramatically and making it more feasible to adopt globally. Alright, thank you for those who support me from the beginning, especially my supervisor, Encik Zubir, and also my panels, Sir Mustafa and Dr. Hatta. Thank you so much. I'm signing off.